Just to repeat, so I'm building ResearchGPT. My name is Wojciech. ResearchGPT is a demo product and project of a broader package called PhaseLLM, which is essentially a tool to help build a more robust large language model powered apps. What I will be doing today is talking a little bit about the actual architecture of ResearchGPT, how we've organized the entire project. It is all open source. I'll share the links for that as well, and I'll walk through literally like how the prompt chaining works, as well as some other interesting things that we're doing now. I've preloaded the demo with 3 different models. One is with GPT-4, one is with GPT 3.5, and one is with Claude. The nice thing is about where things are going, both with PhaseLLM as well as more broadly, is just the fact that you can plug and play these things. So here it is. Again, it's all open source. You'll be able to see how to run this later as well. And the data that I've preloaded is some public domain census data. So in this case, you see here, I'll zoom in a little bit more, although the layout gets a little wonky when I'm ultra zoomed in, so bear with me. But we've got a few different variables here: age, work class, education, marital status, occupation, relationship, race, sex, hours worked per week, country. Now, this is the US Census, but this is the native country where people come from, as well as income. And in this case, it's actually a binary variable, less than 50K, greater than 50K, but these are strings, which I want you to keep in mind when we start asking this thing questions. Okay. So with that in mind, I'm going to ask this a very simple question, but if you want to throw a question into the chat next, I'll try to pick one so that you know I'm not just simply cherry picking examples that don't crash the system in any way. So the question that I will ask, that is a fairly simple one that I've pasted, is just what's the correlation between age and hours worked? So 2 numerical variables. You know, we can all probably do this in a pandas data frame in like 5 seconds. Let's see how this model does. This is GPT-4. I've got a second one here, which is Claude. I'm going to submit it as well. And then the last tab is GPT 3.5. So I'm submitting it to all 3 of them at the same time. We'll see who responds first and how quickly. Normally this analysis takes 1 or 2 minutes, but again, we'll see what happens. Okay, so one of them's already crashed. And while I'm getting this up and running, so Saber, what application have you used for the UI? Custom built, literally vanilla JavaScript and CSS. I'll take that as a compliment in some small way. So thank you for that. Okay, so we've got some results here. So this is, remember, this is GPT-4 6003. That port in this demo is GPT-4. All right, so what's the correlation between age and hours worked? Correlation between age and hours worked is 0.068, rounded to 5 decimal places, close to 0, indicating weak positive relationship. In other words, as people get older, the work hours per week do not increase or decrease substantially. All right, thanks GPT-4. The other thing that I want to show very quickly is the code itself that's generated. So import, you know, so this is actually what's running. The other thing is the Python output itself, correlation coefficient between age and hours worked. Someone's asking about how this is different from ChatGPT. I will get to all of that in my presentation, because it's, in short, I am not sharing the data with any of the large language models themselves. That's a really big component to this, and everything is actually running locally. Let's see what happened here. So this is Claude. All right, this kind of worked as well, which is nice. The formatting is not perfect, but same idea. This is the correlation coefficient. This is the evidence to support. I won't read all of this, but there you go. And GPT 3.5 also seems to have worked, which is awesome. And you can see it's a little bit different. I won't read this, but in all 3 cases, this worked. So let's do a more complicated one. Amir, I like yours. What is the correlation between capital gain and country of origin? I like it because if you remember here, country of origin is obviously categorical variable, So, and there's also missing values. There's a question mark here. So let's see what happens if we submit these. So the let's maybe wait a second or two. While that's happening, I'm just going to jump to this. If you are curious, these are the links themselves around all of this. So ResearchLLM is basically developer tools for building LLM powered apps like this. We are building our own exception classes. We're building our own chaining solution as well. Very similar in some ways to LangChain, different in other ways, which I'm happy to talk about. All of ResearchLLM is open source. So go to GitHub, like us, fork us, submit issues, whatever you want. And lastly, ResearchGPT is a demo product here as well. So you can obviously run all of this yourselves as well if you'd like to do so. And again, if you have specific questions, feature requests, etc., it's very much an active project. We actually only launched on Tuesday, so it's been a pretty busy week. Okay, let's see what happened here. So correlation coefficient between capital gains and country of origin is basically 0. And this is GPT-4, port 6003. Let's see the code itself. So this is getting a little more interesting, right? It's actually doing, it's importing something from sklearn called label encoder. It's copying the data frame and calculating the correlation coefficient. I'm going to see the Python output itself. So in this case, so this is one of the things that we're still working on. You'll notice that in this case, to someone's question, we are running a Python interpreter in the background. And so what we're doing is hijacking the print calls in this case. So one of the things in the prompt itself is actually requesting that the model write print commands so that it can be sent that data. So this is the only thing it's getting in this specific case. What happened with, so Claude is still running, plugging away at this, and so is GPT 3.5. Surprisingly, usually GPT-4 is the slowest one, so this is interesting. So we'll keep it running for a few minutes. We'll see if it does anything. Sometimes this stuff ends up in a bit of a loop. I have like 4 terminal windows open, so nothing's actually aired out behind the scenes. So we'll see what happens. So this is the vision, the idea behind ResearchGPT and what we're doing. I'll talk a little bit about why we've started building this and also how this works, especially given some of the questions that have come up. So first of all, what do I want? As a user, like I'm a former consultant. I care deeply about analyzing data, and I also have a very strong opinion about whether large language models can generate new knowledge, which I'm going to briefly talk a little bit about, and I'm happy to debate in various ways today as well. But the basic idea here is I want a large language model to analyze my data and do my research for me. I've seen the AutoGPT demos. I've seen the baby AGI demos. All of that is really cool. I don't care about you running my Twitter feed for me. I might want you to run a business for me and generate a passive income without me doing anything, but I don't think we're quite there yet. What I do want is to give you a data set and actually have you start exploring the data, you being the large language model. However, I don't want to share the data itself. Number one, I know the context window is too small, so importing the data itself is going to take, it's impossible. Like I can't just share the data with you. Although for smaller data sets where I've tried this, sometimes it actually works interestingly well. And ultimately, what I want is I want to build a workflow where I'm not simply asking you to analyze a data set for me with specific commands, but I want to actually create chain of thought reasoning process where you build the whole project for me and maybe even an agent that goes out and searches the web for results, but we're not quite there. The important thing is, especially from an enterprise context, I don't want to share the data. I want, and this is my data according to Midjourney, by the way, if you're curious. So there you go. So again, you've seen this screenshot. I won't go into this, but here's how the actual process works. So going back to this, okay, these ones are still running. That's I'm going to just assume they crashed in some way, although I'm literally waiting for a response from the models, which is interesting. So whatever. What I want to do though is I want to interact with the data itself, and you saw this screen. So how does this actually work, right? The very first thing that we do is actually, we have our local data in a CSV file. We load it into a data frame. It could be Excel, it could be SQL, doesn't really matter. That's all running on a local server. And the very first thing that we do is create a really specific prompt around requesting that the large language model specifically be our data science assistant. This is like the least interesting prompt of all of them, but I did want to call out a few things. We ask for one Python code block. We also ask it to specifically write, yes, if the model understands this, or no with follow-up questions if not. The very first thing that, the reason why we do this is that I want to make sure that the model itself is actually acting in some sort of predictable way. So in this case, just as an example from earlier when I was testing this out, I'm running ResearchGPT with Claude here. Its first response to, did you understand this, was yes with a capital Y, really small issue, but it is still technically an issue, right? It's not actually following what I asked about. So there's an LLM response exception. This is one of the exception classes that we've built specifically to robustify these types of models. When these exceptions happen, we save the prompt, we save the response, we save the model settings so that we can explore and debug later as well. Now, in this case, what I do is I have 3 attempts to launch this Flask-powered, Flask-enabled app, and in this case, in the second attempt, it did actually succeed. Now, this is a pretty simple example. Claude is really good at saying yes to understanding the instructions. When we've tested this with other models, whether that's Bloom or Cohere, this actually becomes really tricky. They're very finicky. They ask follow-up questions. They almost never say yes in the way that I want. And so again, this is one of the experiments that we're constantly running and testing. So then this is what you get, right? With that startup prompt, you get this. And the other piece that I do want to call out here is this data overview. So in fact, I'm going to zoom in a bit more here. So what we're doing here is we're actually writing a set of functions that that specifically describe the data that we are sending through itself. So we're telling it what environment we have. So in this case, pandas, numpy, scipy, sklearn, df contains, and df is the data frame that we've loaded, contains the following variables. So we describe every variable along with the values that that variable has in the case of categorical variables in data. And that's it, right? At least in terms of the description of the data itself. Now, now the second thing that we do, this is the actual data prompt. So that data setup intro, data setup intro, we tell it what kind of research we're doing. Then we provide the information that I just mentioned. So there's a function that we provide in ResearchGPT that generates the overview. And then we insert whatever question we have. So one of the things that I want to emphasize here as well with this data prompt is we're resubmitting this for every single message, which feels like overkill. But as we've sort of run all our tests, it feels like the most robust way of actually setting up this this data analysis process. Constantly reminding GPT-4, Claude, et cetera, that here's the data, here's what it looks like. If we don't do that, it starts making assumptions about the data, which obviously can break things since it can't do that. And then this is the actual flow for every single message. And so the question on how is this different from ChatGPT, this is like really where things break down. So we've got the data prompt, we ask it to generate some Python code, then we run the code locally. Right now it's not sandboxed in any way, but as I think about making this something that is completely available, like publicly, we will be sandboxing it more robustly, but again, that's coming in the next few weeks. So what actually happens here is we have a set of agents that do things for us. The first one is this code execution agent, runs things locally, saves the output. The second piece is error tracking. So again, similar to the error that you saw with Claude earlier, we've also written specific exceptions to capture LLM generated code exceptions. We do this for 2 reasons. One is, again, we can check the prompts, we can debug them or just analyze them ourselves. Is it a prompt issue? Is it a data output issue, or is it something else? And there's a third piece here, which is we've built our own chatbot class to abstract this process. Again, Cohere doesn't have, as far as I know, like a chat interface. GPT-4 and GPT 3.5 very much do. Claude has its own approaches to this thing. So obviously we've just abstracted all of this. The other reason that we've done this is we actually have the workflow behind the scenes here where, the common approach to doing this with a chatbot, like a chat interface would be, okay, I ran the code, I got an error, can you please fix the error? I find that this also breaks things down a little bit when we're working with such a large set of variables and features. What we actually do instead is we remove the last few chat components that have led to the error and we regenerate them. And the chatbot resubmission piece here is we also include an updated prompt that specifically talks about making the model or asking the model to be sensitive to specific types of errors, including X or Y, whatever the errors were here. And again, it's technically forgotten or it doesn't have access to that message that created the error because we've removed it from the chat flow. But we just want it to be sensitive, and we find that it actually helps. Now, in this case, we only retry the code once before erroring out, just because we don't want this to go into an infinite loop. Some really interesting things here that came up in the last talk as well. There's no reason why we have to limit this to one model. One of the things that we've been exploring, for example, is GPT 3.5 is pretty good. If it errors out, we can upgrade to GPT-4 or again, use Claude versus GPT-4 if we want to, for whatever reason. Again, potentially to robustify things a little bit. Next, what we do, so remember, we ran the code locally. We have the output, and so then we have a pretty simple prompt, frankly, where we write the following is the output of the code, include the code output. Could you please interpret this for me? Justify your answer by including the outputs of the analysis. So this one I think is pretty straightforward from a workflow perspective. And then of course we have the final chat output. And of course, what's cool about this and where we've seen this go is that it doesn't have to be a very obvious question. So this is kind of a bit of a jokey submission, just a screenshot, right? I bet married people work less. Again, that converts to code quite nicely as well. There's no reason why it has to be like, here's a correlation analysis I want to run, or please build a logistic regression. You can be a lot more flexible than that. So going back to the demo here, as an example of this, one of the things that I really like, I'm just going to paste this in. I'm just going to run it with GPT-4 in this case. Is there's the question here is build a model to analyze how age, gender, and hours worked impact whether you earn a lot or not. Please provide an interpretation of the results too. So I'm going to submit that. I'm going to, again, wait a second or so just to see what happens. While I do this, is there any questions here that that have come up? All right, so with LLMs in the picture, is it necessary to have deep knowledge of deep learning or just using LLMs and fine tuning them? I think this is a good question. I think there's going to be, okay, sorry, and then Ken, you have a great question. Okay, so I personally have an opinion on the LLM piece. I think that in the short term, you could probably build some really cool apps without having much knowledge around large language models. This is, I think, a good example, right? A lot of this is just like prompt engineering and maybe like software engineering in terms of like exception classes and creating more robust workflows. My personal opinion on this, however, is that the moat for something like this is pretty minimal too, right? Like, it's one of the reasons why we open sourced all of this is you can run it yourself. It took maybe 20 hours to actually build all of this out. It's not a huge a project from that perspective, like ResearchGPT specifically. Where I think the opportunities is really understanding how to build the right type of large language model and which large language models to use within which situations and scenarios. And this is the idea behind ResearchLLM, frankly, is actually making sure that you're picking the right model, that you're recovering nicely from errors, that you're also dealing with what I would call kind of non-deterministic errors. This is something that ResearchLLM is going to be publishing about in the next few weeks. the idea that you also need to actually like deal not just with simple like code execution errors in this case, but is the model actually interpreting the results properly? Are the when it's given a correlation coefficient, does it actually use the numbers you're giving it, or does it do something else that's funny or weird? And lastly, okay, this other question, oh, sorry, Ken, I want to go with Ken first. So I'm going to go in order here. Does ResearchGPT assume the data is clean? No, and I'm going to come back to this in a minute, actually, because one of the next steps here is around chain of thought reasoning. We don't have that built into a ResearchGPT yet, but we do have a branch where we're exploring this, and I have some initial outputs that that I think are pretty exciting. Okay, going back to this quickly. So an error occurred while executing code. Okay, so this did not work out. So what happened behind the scenes is we asked GPT-4 to build the model, didn't work. Then we resubmitted that question one more time, still didn't work. So let's see what happened here. So first thing I do want to bring up is it's actually doing a really good job, I think, of writing the initial code, right? And Ken, to your question, so pre-process the data, convert gender to numerical values. All right, that's pretty cool, right? One hot encoding, extract the relevant data. Okay, cool. Also doing the same thing for the income variable because it knows it needs to be binary and it has strings. It's building a test and training data set and a logistic regression, which is awesome. Where the heck did it error out? So let's see the Python output. Okay, unterminated string literal. So this is really weird, by the way. I've noticed this a few times. You see this here? I'm gonna zoom in a little bit. All of the models keep doing this. It's bizarre. Like this, like think about it. Like it just built the entire thing, and the thing it screwed up on is this. Like what the hell? So there you go. And that might be also partly because of the way I'm executing the code. But anyway, there you go. So one of the things with the workflow that I mentioned is we did resubmit this, right? We specifically said, be careful about unterminated string literals. It still made the mistake. So lesson learned, not a perfect system, but frankly, pretty exciting about the code that it did right. Okay, so just to actually, I'll keep going with Ken's question before I conclude and talk about the other questions that people might have here. So in terms of next steps, there's a few things that we are working on right now. So chain of thought reasoning. So far, this is kind of neat, but again, it is a pretty back and forth conversation and dialogue, right? It's not really doing a ton. I'm still driving the questions, and my goal, if you remember, was I want you to actually do the research for me and come back to me. And so one of the things, again, late night, last night results, we do have this branch if anybody's curious, called COT, Chain of Thought. And what we do here is we actually have a slightly different approach here. What we say, let me see if I could get the code itself. So bear with me. Okay. So in this case, we again resubmit the full data structure and everything else, but we have a specific question that we start with instead, which is I'm researching the relationship between income and socio-demographic census information, just like before. But with all of the above in mind, could you please provide me with a set of analysis steps, and could you recommend steps that you would recommend I run to better understand the data? Don't visualize this because I'd like to ensure the outputs are something that you could interpret, and I ask it for code itself. And again, there's a few steps here I won't go into because you could check the code itself, or if you have the questions, I'm happy to go into more detail, but basically this is the output. We generate a markdown file. This chain of thought analysis plan is literally generated specifically. Actually, I'm going to do the raw. I think that'll look better. Yeah, all right. This is fully generated by GPT-4 in this case. So describe statistics and descriptive statistics and data cleaning. All right, income distribution analysis, correlation analysis. So it's going through each of these steps. Obviously, it's just writing it down. But then what we do is for each of these steps, we loop back and say, hey, can you actually write the code itself for us? And so, of course, here we've got every single step. Code for step 1. Sorry, this is kind of confusing because this is Markdown, but then we've got the Python, right? So code for step 1, again, it knows which variables or columns are numerical, knows which ones are categorical. It starts cleaning things for us. The code for step 2, income distribution analysis. Step 3, step 4. I'm not going to go through this. You get the point, right? So this is one of the things that I'm really, really excited about incorporating back into this is, hey, let's actually run the full analysis. Let's give you the outputs of everything, and then let's see what happens. The other pieces that I do want to work on in the coming weeks with this, of course, is other agents. So there's no reason why this can't go off and look for data if you have a broader question, or even potentially build its own data set. Memory, of course, I won't talk about because I think there's a few people talking about things here. And of course, more broadly, the vision behind all of this is research automation and new knowledge creation, right? Like the goal here is, again, we could debate whether large language models synthesize new knowledge via their weights and things like that, but which I think is a fascinating debate. But the other piece here that I think is really, really interesting and important is, hey, if I'm an analyst and I'm not comfortable coding, or I'm not comfortable, or I don't even know where to start, or I just need someone to do the basic stuff for me, why don't I just outsource all of this and have this model come back to me with the results? So that's the vision behind all of this here. If you do have any questions, my email is w@phaseai.com. If you want to follow up, but again, feel free to go to phasellm.com to download the code, and again, check us out on GitHub as well if you'd like.